This is Mrs. Zappia with Lesson 22, using sample data to compare the means of two or more populations. Student outcomes for this lesson. Students express the difference in sample means as a multiple of a measure of variability. Students understand that a difference in sample means provides evidence that the population means are different if the difference is larger than what would have been expected as a result of sampling variability alone. In previous lessons, 7th graders have been challenged to learn the very important roles that random sampling and sampling variability play in estimating a population mean. This lesson provides the groundwork for Lesson 23, in which students are asked to informally decide if two populations' mean differ from each other using data from a random sample taken from each population. Implicit in the inference is sampling variability. Explicit in the inference is calculating sample means and the process of comparing them. This lesson develops a measure for describing how far apart two sample means are from each other in terms of a multiple of some measure of variability. In this lesson, the MAD, mean absolute deviation, is used as the measure of variability. In previous lessons, you worked with one population. Many statistical questions involve comparing two populations. For example, on average, do boys and girls differ on quantitative reasoning? Do students learn basic arithmetic skills better with or without calculators? Which of two medications is more effective in treating migraine headaches? Pause the video and copy the essential question. How can we describe the difference between two sample means? Tanika's mathematic project is to see whether boys or girls are faster in solving KenKen type puzzle. She creates a puzzle and records the following times that it took to solve the puzzle, in seconds, for a random sample of 10 boys from her school and a random sample of 11 girls from her school. On the same scale, draw dot plots for the boys' data and for the girls' data. Comment on the amount of overlap between the two dot plots. How are the dot plots the same? How are they different? Start with a line for the boys, a line for the girls. Label your number line from 25 to 47. Go ahead and place a dot over each number. If a number appears more than once, remember to stack the dots. Pause the video and complete number 1. This is what your dot plots should look like. When looking at the overlap, we want to see the dots from the boys and the girls that appear on both dot plots. The dot plots appear to have a considerable amount of overlap. The boys' data may be slightly skewed to the left, which means more data on the right, whereas the girls are relatively symmetric. Question 2. Compare the variability of the two sets of data using the MAD, mean absolute deviation. Is the variability in each sample about the same? Interpret the MAD in the context of the problem. The variability in each data set is about the same as measured by the mean absolute deviation, rounded to the nearest whole number. The MAD for both boys and girls is 4. A typical deviation from their respective times, about 4 seconds. In the previous lesson, you learned that a difference between two sample means is considered to be meaningful if the difference is more than what you would expect to see just based on sampling variability. The difference in the sample means of the boys' time and the girls' time is 4.1 seconds. And you subtract 39.4 minus 35.3 to find that difference. This difference is approximately 1 MAD. So the difference, that's the difference between the sample means, and we have the girls minus the boys, and that gives us 4.1 seconds. The number of MADs that separate the sample means is 4.1, which is the difference, divided by the greater MAD. 4.04. And we get that from the data right up here. When you do that division, you get 1.01. And so that is about 1 mad. The number of mads that separate the sample means is about 1. This formula you'll be using quite often, finding the number of mads that separate the mean. We'll be practicing that. Question A. If 4 seconds is used to approximate the values of 1 mad for both boys and for girls, what is the interval of times that are within 1 mad of the sample mean for the boys? The interval would start 1 mad below and extend to 1 mad above. 1 mad below. So we have 35.3, take away 4 seconds, and that gives us 31.4 seconds. And then above would be 35.3 plus 4 seconds. So you subtract 4 seconds to find the lower part of the interval, and you add 4 seconds to find the upper end of the interval, which is 39.3. So the interval of times within 1 mad of the sample means for boys is 31.4 to 39.3. Again, you start with the mean, and then you subtract the mad, and you add the mad. Question B. Of the 10 sample means for boys, how many of them are within that interval? So we look to see 39 is within that interval, and the interval that we're looking for is right here, 31.4 to 39.3. 38 is within that interval. 27 is not. 36 is. 40 is not, 27 is not, 43 is not, 36 is, 34 is, and 33 is. And so 6 of the sample means are within that interval. Question C. Of the 11 sample means for girls, how many of them are within the interval you calculated in Part A? So let's take a look at that. The interval, we start with 39.4. and we subtract 4 seconds. Then we start with the mean, 39.4, and we add 4 seconds, and that gives us 43. So the interval of times within 1 mad is between the times of 35.4 seconds to 43.4 seconds. Now the question is asking how many of the girls' times are within that interval. So we take a look. 41 is in that interval. 33 is, 42 is. Now 47 is outside of that interval, so we don't count it. 38 is, 36 is. And so the answer, there are 7 of the sample means that are within the interval. Question B. Based on the dot plots, do you think the difference between the 2 sample means is a meaningful difference? That is, are you convinced that the mean time for all girls at the school, not just this sample of girls, is different from the mean time for all boys at the school? Explain your choice based on the dot plots. So again, the difference between the 2 sample means is about 4 seconds. And the question, is it meaningful? Meaningful at this point is an opinion. We have not really discussed much about what number it needs to be meaningful. We know that the boys have 2 times that are quite lower, and that's right up here. The girls have 2 times that are quite higher, and that's right over here. Overall, the data is quite similar. There is quite a bit of difference, but I'm not convinced that it's meaningful. Examples 4 through 7. How good are you at estimating a minute? Work in pairs. Flip a coin to determine which person in the pair will go first. One of you puts your head down and raises your hand. When your partner says start, keep your head down and your hand raised. When you think a minute is up, put your hand down. Your partner will record how much time has passed. Note that the room needs to be quiet. Switch roles. Okay, so first we'll go ahead and do that. And we have quiet estimating for a minute. And here's what we found out. Our data is 58 seconds, 57 seconds, 60 seconds. So one person estimated the minute exactly correct. 57 seconds, 57 seconds, 55 seconds, 65 seconds, 63 seconds. So these last two people overestimated when a minute was up. It was actually less time than they thought. 59 seconds and 56 seconds. 62 seconds, 58, 55, and 64. So that was having people estimate when they thought a minute was up, and there was no talking involved. Now, the next one is to switch roles, except this time you talk to your partner during that period when the person has his head down and is indicating when he thinks the minute is up. Note that the room will not be quiet now. So we press the timer and we talk to the people who are estimating the time, and that maybe keeps their mind off counting a little bit. And here's what we found out. They raised their hands after 74 seconds, 60, 66, 66, 65. So what you're noticing here, take a look at the data, is that people are raising their hand after the whole minute is up. So they're maybe preoccupied and not thinking about the time as much and not estimating it as well. Continuing, we have 59, 63, 70, 62, 66, 62, 64, 67, and 65. So we've got our set of data. Number 4, calculate the mean minute time for each group. Then find the difference between the quiet mean and the talking mean. The mean of the quiet estimate. So what we want to do is we want to add up all of the quiet times and then divide by how many times there are. Then we'll do the same thing for the talking. Add all of those and divide by how many numbers there are. Then we want to find the difference between those two means. And remember that difference means to subtract. Pause the video and complete question 4. Our mean for quiet time is 59 seconds. Our mean for talking time is 64.9 seconds. The difference between the two means is 5.9 seconds. On the same scale, draw dot plots for the two data distributions and discuss the similarities and the differences in the two distributions. So you want a line for quiet, a line for talking. The lowest number we need is 54 and the highest number we need is 75. Pause the video, copy down the template for your dot plots. Then plot your data. Remember, if a number appears more than once, to stack the dots. Your dot plot should look like this for quiet and this for talking. Now, discuss the similarities and differences in the two distributions. First, notice that there is overlap between 59 and 65 seconds. When you're looking at the overlap, you want to look at where the dots are in common on the number line. So starting from 59 all the way over, now here they're not overlapping, but if we go back here, these are overlapping. So the overlapping section is actually between 59 seconds and 65 seconds. The quiet group is pretty symmetric. In other words, the data is spread out pretty evenly between the left and the right. The talking group is skewed right, meaning there is more data on the left. The variability is bigger in the talking group. it's 15 seconds versus 10 seconds in the quiet group. And remember, when you're looking at the variability, you're looking at the numbers from the lowest spot to the highest spot. So there's the variability for the quiet group. And here's the variability for the talking group, 59 to 70. The quiet group centers around 58 seconds. Remember, when you're determining where it is centered, here, how many dots are there, and then divide them in half. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 dots. So we have 1, 2, 3, 4, 5, 6, 7. So the centering is right about there at 58 seconds. And the talking group centers around 65 seconds. So that's a good way to estimate the mean of each group. Number 6, calculate the mean absolute deviation, the MAD, for each set of data. Now, when you're calculating the MAD, what you want to do is you want to subtract the mean and the data point. So here we have 58 minus 59 is 1, 57 minus 59 is 2, 60 minus 59 is 1, 57 minus 59 is 2. Notice that we are only writing down the positive difference. We want to know the distance from the mean, and distance is a positive number. Pause the video and continue subtracting each data point from the mean. Next, you want to add all of those numbers together. So we're going to add together 1 plus 2 plus 1 plus 2, etc. You're going to add all of those together, and then you're going to divide by how many differences there are. When we add those together, we get 38. And we know that there are 14 data points. 38 divided by 14 is our MAD of 2.7. Pause the video and find the MAD for the talking group. Remember, number 1, the means were calculated above, so we're going to use the MAD of 64.9. We're going to subtract that from each data point. Then add those distances and then divide by 14. Pause the video, resume it when you're ready to check your work. And so the MAD for the talking group is 2.8. Continuing with that question, it said, is the variability about the same? Interpret the MADs in the context of the problem. The MAD measurements are about the same, 2.7 and 2.8, indicating that the variability in each data set is similar. In both groups, a typical deviation of students' minutes estimate from their respective means is about 2.7 seconds. Question 7. Based on your calculations, is the difference in mean times estimates meaningful? Part of your reasoning should involve the number of MADs that separate the two sample means. Note that if the MADs differ, use the larger one in determining how many MADs separate the two means. Okay, so this part here, you want to write down and circle and star this equation because we'll be using it frequently. The number of MADs that separate the two sample means is a division problem. The numerator is the difference between the means, so we're going to take the two means and we're going to subtract. Then you divide by the larger of the two MADs. So put a star by that equation. The difference between the means is 5.9. And we see that from number 4. We had the two means here, 59 and 64.9. So we've got the difference between the means, and that's 5.9. The larger of the two MADs. So we had 2.7 and 2.8. You use the larger. Then you divide numerator divided by denominator, and you get 2.1. The number of MADs that separate the two sample means is 2.1, which is a meaningful difference. And we'll talk more about what a meaningful difference is in future lessons. In this lesson, you have learned, using the MAD, I can describe the difference between two sample means. I would divide the difference in the sample means by the larger MAD to determine how many MADs separate the means. Also, variability is a natural occurrence in data distributions. Two data distributions can be compared by describing how far apart their sample means are. The amount of separation can be measured in terms of how many MADs separate the means. Note that if the two sample MADs differ, the larger of the two is used to make this calculation.